Welcome back to the channel. Today I'm going to look at the ZSA Navigator, which is a rollable for the Voyager, and it actually just magnetically clips on to the back of the Voyager here. It's really strong. I probably can't easily sort of take this off without pinging it everywhere, but you can see it does just literally magnetically connect there, which is really cool. It's great that it can be so easily kind of extended like that. So there's a range of things that have sort of come to light after testing this. I've basically spent my whole life trying to pursue reduction in finger and arm movement when I'm using computers. I hate this idea of going back and forth from your home row. Basically, I don't ever want to leave the home row. You know, that sense of efficiency you have when you're just reaching for your keys and you know you're always oriented on that home position, and having to move that and break that to get to a pointing device, I've always felt a very disruptive kind of part of working with computers. So I've always been really interested in this idea of how we can solve this. How is it possible to use a pointing device without leaving that home row position? This is the closest I've got to this so far. You know, before this I was using the trackpad. I'd either have the trackpad just to the right or in the middle of the two halves here. Now I still can't actually use it from that home position, and this is interesting because we've got the thumb cluster here that I'm not actually using on my layout. My thumb key is now the inner column bottom row, but I can't obviously put the rollable down where those thumb keys would be. So we are sort of stuck with it in this position. I think ZSA's intention was that people would use the rollerball with their hand like this, and then maybe use the left hand for the click. Now this is interesting. Obviously, this rollerball has no click buttons. It's in its own right. I think that's absolutely fantastic. The idea is you just use keys on the keyboard for your click events, and this is just brilliant. So by default, it has this mode where it will switch to a mouse layer when the rollerball is detecting movement. Now that was problematic for me because the first time I used it, I had it upstairs on my sort of arm that's a little bit wobbly, and actually when I'm typing on that, there is a fair bit of movement, and that in itself is something that I was keen to solve separately. It is definitely a suboptimal setup. So this really isn't a kind of fault with the rollerball. It's just sort of, it highlighted the inadequacy of my setup in that respect. So every time the board wobbled, that would then detect the rollerball's movement, switch to the mouse layer, which of course would stop the typing that I was doing at that point in time. So that was a little bit problematic in that respect. But I was so keen on getting the most out of this and testing this out that I actually switched back to this kind of setup. So I'm kneeling on the floor, and I'll do the same thing upstairs, and I would put the board back onto a little stool in front of me like this so that I could use it with much more stability, and that obviously solved that problem. But I did also find that I was actually happier having a manual layer switch rather than letting it do this automatic thing. It just felt more predictable to be able to have that layer switch. So actually what I do when I use this, I move my hand one key left and one key up from the home position. That then becomes my mouse position. So that is the extent of the movement from home row keyboard to pointing input on the right hand. The left hand stays on the home row, of course. And there's a really important reason for that, because I've got this setup, which is probably one of the best productivity hacks I've ever come up with, to have the mech key on hold on your thumb space on the left hand. That means you can switch application spaces in a tiling window manager just by tapping the letter keys when you're holding down your left thumb. So sort of, you know, home row position, application switching on the left hand, which of course means if you want to drag something from one application to another, you need to be able to do the clicking fully with the right hand. And I think that sort of workflow possibly, I can't really see how that could work if you're putting your middle fingers on the ball, because, well, I mean, then maybe you could use the left thumb keys for click with the right thumb if your halves are close together like that. But other than that, you know, it's going to get a little bit awkward as well, isn't it, if your left thumb is there. Obviously, I appreciate my not using the thumb keys is a little bit unusual. You know, having the thumb keys on the inner column bottom row is definitely pretty unusual. And of course, I've lost the space for a key there, so I have Z on a combo. Combos, I would like to see click events being supported by combos. So at the moment, I'm using this layer switch to get into the mouse layer. So when I move my hand up one and left one, that index finger there is what I hold down to put the board into the right layer, and the left half is fully transparent in that layer, so the application switching the mech key and the letter keys still behave as if they're in base layer, even though I'm actually in the mouse layer. So I can then click with my middle finger, right click with my ring finger, and I can put it into the scroll mode with my pinky finger all on that top row. So this is what's nice about the rollable, is you can put it into the scroll mode, so it becomes your mechanism for scrolling, of course, in any direction in your application, which is fantastic. So just hold down these two fingers basically, and then the ball will scroll for me, and that is excellent. I really like how we're just using the ball for so many things. And of course, on decent operating systems, I love the Mac OS, but actually it's so frustrating that it doesn't support this Alt Zoom scroll thing. So on Windows, you can hold down the Alt key, your scroll wheel becomes a zoom. It's just like through the operating system. In Mac OS, they've hobbled this. They want you to use the pinch gesture on the trackpads, and obviously the mouse supports that as well. So they want you using all these gestures, and they've hobbled the experience if you're using a standard scroll input, which is incredibly frustrating because it would be just so easy to hold down Alt and turn this into a zoom. Some applications that are kind of cross-platform native, they do support this, so that's like nice to see, but it would be just fantastic to see there's like zooming a timeline in Final Cut Pro. There's no obviously easy way to do that with this rollable, which is so frustrating. But no fault of obviously ZSA with the rollable design there. So the next kind of issue that I have with this, and now all of these are solvable, which we'll get onto in a minute, with the biggest strength of all of this thing. But obviously on my setup upstairs, when I have it on the arm and on the tripod mounts, I'm used to a very extreme tent. I think this kind of a tent is fantastic. It's the only way I've found that stops that pain at the top of your shoulders, that sort of tension, soreness at the top of my shoulders from using keyboard if I'm not tenting extremely. And I don't know if that's actually as a result of being able to drop my elbows a bit lower, which is a byproduct of having the extreme tent. I mean, obviously you could potentially not have the tent with your elbows down there as well, but it's just so comfortable to have the tent and the elbow drop. I don't get any pain in my shoulders. I can type all day like that. Back to a desk orientation with my arms a little bit higher, my forearms a little bit closer to level, and removing the tent, I do get that tension coming back in my shoulders. So I'm a big fan of an extreme tent. Now with the Navigator, with an extreme tent, you have a bit of an issue because this crown that the ball sits in becomes at this angle. And I have this sort of natural tendency, obviously I'm using this with my thumb, not the hand, so I'm not pushing down. This is all kind of leading to this problem. But what happens is I naturally end up pushing slightly on the side, and that is enough just to unseat the ball a little bit every time, and that's very frustrating when you're trying to scroll. You can hear it clicking and it just jumping out, and that's unfortunately makes that quite problematic. Now the reality is ZSA have built this thing in a really interesting way. First of all, this whole module can actually work with any QMK board. It's not even limited to the Voyager. That in its own right is super interesting. But this piece, the crown, and this piece, the base plate, are simply plastic parts that can be fully disassembled. You just unscrew it all, and inside there you've got the actual module. This is just this tiny bit here. That's the only part of it, and then you've got your TRS cables that go into that, and there's daisy chains into the existing TRS connection between the two halves. But this piece and the crown, you can 3D print your own versions of these, and people are doing this already, and the models are going to be obviously sort of coming into the community to allow for this. So all that would need to happen is this base plate angle can be twisted down like that, or the crown kind of twisted up like this a little bit to resist that angle input from my thumb and stop it doing the bouncing out thing, and then it would be fine. Obviously gravity would be holding the ball in the right position, and you could use your thumb with that downward force, which is kind of going that way against your hand, which is obviously the natural orientation for your thumb, like this. So to shift this that way so that my hand can stay like this on the keyboard will be fantastic. So I've got to start getting into 3D printing now. I'm going to have to find a 3D printer. Definitely super interested in trying this out though, because I think that setup would be really, really cool. Now, obviously, there is also this fundamental problem of the position of this ball in respect to the home row. It's a little bit of a shame to still have to move one distance from my home row. Now, I've kind of made my peace with this idea of actually just moving only one key up and one key left to do to switch to using the ball. I think that is acceptable. I don't know if I really want to keep pursuing this idea of trying to use the rollable with no movement from the home row at all. I think it would be quite cool to be able to pull that off. But to do it, really the only way is to put the ball where this thumb cluster would be. But of course, this is compatible with custom keyboards. So if I was to build my own custom version with no thumb cluster key positions, the ball could be positioned under my thumb here in this position. And now this is really interesting. This is where it all comes together with the offset on the pinky column. Now I've spoken about this before, but a kind of minor offset on the pinky column, like we have with the Voyager here, means that your thumb is under the board rather than on the inside of the board. So with an extreme pinky column, I could rotate like this, which would put my thumb actually much closer. But because of the shallow stagger, it's actually when you're using it to be able to use these columns with your fingers like this, you end up rotating your wrist across the board a little bit more, and the thumb comes that way, which is away from that ball. So, and of course, this is probably relative to your pinky length. I mean, I've got quite short pinkies compared to the middle finger. Maybe that means I'm going to be finding it easier to use the extreme stagger boards. If you've got a longer ratio, I guess, of these three fingers, then you might find your thumb is more naturally in this position, and you can do this from the home row. So that all comes into this as well. This is always this interesting relationship between the pinky stagger and the thumb cluster position on that arc, on the inside, at the lower inside of the board position there. That is, of course, why for me I have to move my hand up and one to actually get my thumb onto that ball. So overall, this is a fascinating first attempt at solving this problem of a massive reduction in arm movement between the keyboard and your pointing device. This is something I've been seeking my whole life, and I'm super excited to have got to a point where actually I can use this. And even on my arm, I've actually worked out how to make that stable enough now so that I can use it with a much less aggressive tent, but still on the arm, so I can still move it from sitting to standing and experiment and move around a little bit, and I just brace my arm against a stool, which gives it enough stability to use this. But I have turned off that automatic layer switching, because I think if I'm still typing quite vigorously, it would still be enough to just trigger that layer switch with the pointer. So turning that off and just using a normal layer switch on that index when I move up and to the left, I think is a good shout to solve that problem if you have something that is a little bit sensitive to vibration, because obviously the worst thing in the world would be for it to switch into a mouse layer while you're in the middle of a word. But I think the fact that ZSA support this on other QMK boards as well, apparently they're publishing their fork of QMK that includes support for this, so you can use that version of QMK on a custom board or something like that. I haven't gone super far down that road yet, but I'm getting more interested in the idea of trying to build another board now that maybe uses this in a way that I don't have to move from that home row position. So watch this space on that. It's amazing to think that you can just 3D print your own arrangement for this, still using all of their main kind of sensor, optical sensor and all the rest of it, and still being fully supported through their entire platform. So a really interesting addition to the ZSA Voyager. I think this positions it, and it's always interesting kind of it discussing where this is positioned in the market, because obviously you can go so much further in terms of the custom keyboard route. You can have 3D printed sort of keywell designs, which I'm very interested to try. I'll hopefully go down that road, and of course that naturally ends up with a nice position for the ball on the thumb side, inside, on the outside of that keywell. There are quite a few boards that do that. Fully customizable wireless with ZMK and all the rest of it. This is using a wired QMK setup, and I think a lot of people are sort of trying to struggle to make their peace with that when there are these wireless boards out there. Obviously it is what it is. It makes it very accessible. Obviously they've got their web-based customization tool for the layout. If you're wanting to just do a one and done keyboard, it will let you customize your layout, improve your ergonomics quite significantly as a result of doing those kinds of tweaks, let you experiment with different layouts and not have to worry about any custom configuration at all. Just literally do it all in the web browser and then sync it to the board and you're done. It's a great one and done board for a lot of people, but obviously there are ways you can keep going down this rabbit hole with custom keyboards and fully building your own and using ZMK with wireless controllers and so on. So there are lots of levels to which you can go to this. So I've explored a lot of these avenues over the years, and the only one that I haven't really experimented with is one of these keywell designs, the 3D printed keywell design keyboards, and I'm definitely keen to try one of those. And this is interesting because the reason I think the ZSA Voyager is very compelling is because ultimately it is quite portable. It's still quite faffy with the cables, but it is ultimately quite portable. You can fold it and chuck it in a bag in a way that the 3D printed keywell designs probably just wouldn't be. But I'm actually finding I'm not using this when I'm using a laptop portably now, because I can use Kanata to remap my layout on the actual built-in keyboard. I'm finding that's enough for portable use. I use this in a desktop environment at home. When I'm taking a laptop, I just use the laptop keyboard with my key map on the laptop keyboard, and that's been really amazing. I don't need to think about the main keyboard being portable anymore, which is why I'm sort of interested in the keywell designs. Let me know if I've missed anything or you have any other questions. I think I've kind of touched on all of the important nuances of this in regards to the tenting, in regards to the home row positioning, and those are all kind of really interesting, important things to discuss. I think when you're looking at a product like this, it's all about the impact on your, this motion, this repetitive motion moving from the keyboard to your pointing device. And I think hopefully I've explored that a little bit. So let me know if you have any questions. I'll answer those in the comments below. I'll link to another video on the screen now, and I'll see you there.